Hello friends, today we will discuss large sample test. So normally the large sample tests are of two types. So one which is depends upon univariate case and the another one which is depends upon bivariate case. In case of univariate, there are two types. So one is large sample test for variables and the another one is large sample test for attributes. And you know that variables are nothing but those which are of having a quantitative characteristics. And whenever we are doing the procedure of large sample test for variables, there exists a test which is called as large sample test for mean, in which we are interested in knowing whether the population mean is being taking a specified value of mu naught. So in this case we are testing our h naught is whether the value of mu is same as mu naught. So my h naught is mu equal to mu naught in case of large sample test for mean and single sample. So what we have to do in this case? So in this case we first start with our null hypothesis, and in this case you know that our null hypothesis is h naught mu equal to mu naught, whereas the alternative hypothesis is h1 mu which is not equal to mu naught. So clearly we are testing here the test statistic which is based on mean, and we are testing the population mean mu is equal to mu naught. So we have to take the test statistic which is based on sample mean. So that means x bar, and we know that the expectation of x bar is equal to mu, and the variance of x bar is sigma square upon n. If x follows normal mu sigma square, then expectation of x bar is equal to mu and variance of x bar is sigma square upon n. And as per the central limit theorem, we can show that this z is nothing but x bar minus expectation of x bar, and it should be divided by standard error of x bar. So therefore this is my z statistic value, and since I know that expectation of x bar is equal to mu and variance of x bar is sigma square upon n, if I put this value in this central limit theorem, so z is equal to this value, that becomes x bar minus mu divided by sigma upon root n. And under h naught, my h naught is mu is equal to mu naught. So now my test statistic becomes z is equal to x bar minus mu naught divided by sigma upon root n, so which follows normal 0 1. And now what I want to do, so I have to compare this calculated value of z with the table value of z. And for two-tailed alternative, since my alternative hypothesis is mu which is not equal to mu naught, so therefore this is a two-tailed test, and in case of two-tailed alternative, the critical region becomes probability of z greater than z alpha by 2 equal to alpha by 2, or the value of probability of z less than minus z alpha by 2 equal to alpha by 2. And otherwise we can take this value as z probability of z is greater than z alpha by 2, and if this value is equal to, so that means probability of mod z is greater than z alpha by 2 equal to, so the alpha by 2 the value of alpha by 2 is taken as 0.5 divided by 2, and now this becomes z, table z at 0.025 is 1.96, and therefore the table value of z at 5% level of significance is 1.96. If my calculated value of z is greater than 1.96, then I want to reject my null hypothesis, otherwise I have to accept the null hypothesis. Friends, you have to remember few points in testing of hypothesis as far as large sample test for variable and particularly mean is concerned. So suppose if the sigma square is unknown in this case, then we have to replace it by sample mean square. And what is my sample mean square? The sample mean square value is, so this is S square equal to summation x minus x bar square divided by n minus 1. And for large samples, so that is taken as sample variance. So summation x minus x bar square divided by n. And if the sample is drawn from a population, so that means if I know that my parent population is normal, so that becomes exact sample test. So it is applicable for small values of n, and whenever the sigma is known. And for one-tailed alternative, the test procedure remains the same. Instead of only, we have to change the critical region. So instead of alpha by 2, we have to take in this case as alpha. So this is the procedure of testing population mean mu equal to some specified value mu naught whenever the population mean is taken as a specified value of mu naught. So thank you.